Okay, now we're going to talk about some area separations within the building, or different wall types within the building. And the first wall type that we're going to talk about is a common wall, or sometimes called a party wall, being it's shared by two separate parties, one on either side of this wall. So this is a wall that has to be looked at from a fire code standpoint, and also from a sound control standpoint as well. So the definition of a common wall is a wall between two apartment units that is shared with one side exposed to each unit, sometimes called a party wall. This wall is required to be a 60-minute or 1-hour fire rated wall. Okay, so we know that fire ratings are based in hours. This can be accomplished by one layer of 5/8 type X sheetrock or gypsum board on each side of the wall. This wall is also considered a sound barrier and therefore needs to be properly insulated. This can be done in two ways. Okay. One method of creating a sound wall is to use a 2x6 top and bottom plate and using 2x4 studs, but staggering those studs from one side of the plate to the other. Therefore, the studs need to be, they probably end up being actually 8 inches apart, because they're 16 inches on center on one side of the wall and they're 16 inches on center on the other side of the wall, but the studs are staggered, as you can see in the diagram. And then, therefore, no stud is touching the gypsum board on both sides of the wall. Sound travels through vibration, and the sheetrock touching the stud and the sound waves hitting the sheetrock causes the sheetrock to vibrate, which causes the stud to vibrate, which causes the sheetrock on the other side of the stud to vibrate, which causes sound transmission. So if we can break that somehow by not having those studs connected to both sides of the sheetrock, we can create a sound wall. And then you would wrap insulation through the wall and around those studs. That creates a fairly good sound wall. A better sound wall might be to actually create two separate walls that are close together. In that case, you would have two 2x4 walls with a 1-inch airspace between those two walls. And then there'd be 5/8 sheetrock on both sides of those. And again, you could insulate one of those walls or insulate both of those walls for sound control. So two separate methods of doing it. I think on the project that you're going to be drawing, we're going to do the two-wall system. It is a little bit better sound wall controlled system. So we'll do the two-wall system. But there are more than one way to do it. That's what I've shown you here. Another method of putting some sound control on a wall is to use something called RC1 channel, which is, the R stands for resilient channel, RC1 channel. And RC1 channel, as you can see in the diagram here, is a channel that has a configuration that allows it to be screwed to the stud on one side of the channel, but not on both sides of the channel. And the channel has to be placed so that you're screwing the channel on the bottom side of the channel. Therefore, the channel is what the sheetrock gets attached to, and the sheetrock can vibrate and the channel can move without moving the stud, so to speak. So it's another sound control method. We're going to use this type of system from the apartment unit to the corridor. So instead of using the double wall between the corridor and the apartment unit, we're going to use this type of wall system. So here we will end up using a 2x6 stud wall between the corridor and the apartment unit, and we will put the sound control channel on the corridor side of that stud. And therefore any vibration through that wall would be absorbed by this channel. Again, you'd have to use 5/8 sheetrock. It does have to be a 60-minute wall, but we'll use a single stud wall there, 2x6 studs, and the sound channel. It would be another situation where we could use the staggered stud system on that 2x6 plate as well if we wanted to. The next wall type we'll talk about is the exterior walls. On an apartment building, these are also fire-rated walls because the fire could burn through the exterior wall, go up the wall, and back into the apartment above, so it has to be a fire-rated wall. We're going to use 2x6 studs, 5/8 type X sheetrock on the inside as the inside fire rating material, and on the outside of this wall we have to use a fire rated sheathing material on the outside. Now, a typical OSB or something like that is not a fire rated material unless you get a fire rated OSB, which is fairly expensive. One of the most common types of sheathing on the outside of the building that meets this requirement is 1/2-inch exterior grade gypsum board. So gypsum board, we're used to putting that inside the building as the wall finish inside of buildings. In this case, we're going to use it also on the outside of the wall as the exterior wall sheathing, but it is an exterior grade gypsum board. So it looks different than interior grade gypsum board, and it is a water resistant material as well. So that's the problem with putting it on the outside, but we can get by with that using 1/2-inch exterior grade gypsum wall board, and it does qualify as a fire rated material. It's one method. Other methods, some builders have used an insulation board material. I only know of one that works for that, and it's a product called Thermex, and it is a foam board material that is fire rated and has a foil facing on it, but we're not going to use that type. This is also considered a sound wall. Primarily a sound wall not because people within the apartment are going to be making that much noise, but we want to control sound from outside getting into the building. People are on different patios and so forth, and sound could transmit up through the building. So, but with a 2x6 exterior wall with standard thermal insulation in the wall system and the gypsum board that we put on it, it is going to meet that minimum requirement for that kind of sound control. Floor system. The main floor of this building is going to be built as a slab-on-grade building or a 4-inch concrete floor on the main level. Okay, so 4-inch concrete floor. Concrete, as we know, is very fire resistant. No code issues with that, so that's going to be a fairly simple floor system on the main level. The floor between the first floor and the second floor is, however, a fire-rated floor and a sound control floor from one apartment above another apartment. So again, we have to meet the 60-minute or 1-hour burn rate for the floor system. We're going to accomplish this by using 5/8 type X gypsum board on the underside of the floor framing, and on top of the floor we're going to put a 3/4 inch tongue and grooved floor system on top of the floor trusses. I guess I didn't mention we are going to be using floor trusses. And then on top of the 3/4 inch subfloor on the floor of the second floor, we're going to put a 1-inch layer of gypcrete. So okay, so 1 inch of gypcrete, which is, like I said, a sound deadening and fire proofing system, self-leveling material. On the underside of the ceiling, we're going to put, and here it says 1/2-inch resilient RC1 channel again, which is the same material that we put on the wall of the corridor. We'll put that on the underside between the bottom of the floor truss and the gypsum ceiling material. And there's a little diagram here of what this is going to look like. The upper ceiling, or the ceiling between the second floor apartment and the attic, is also a fire-rated assembly. We wouldn't want the fire to burn through that ceiling, get into the attic, and burn the roof of the building, or burn down into another apartment from there. So we're going to accomplish the 1 hour rating there by applying 2 layers of 5/8 type X gypsum board on the ceiling of the second floor. So the ceiling of the second floor, right under the roof trusses, we're going to put 2 layers of 5/8 type X gypsum board. No sound control issues up into the attic, so we won't have to worry about sound deadening, but we'll go up in with the 2 layers of gypsum to create that. Yes? And we'll talk more about the some of the other requirements up in that attic space later on, but at this point we're just talking the fire rating assemblies. So stair shafts, the stairways cannot be open from one level to another level in this building unless we were to apply, provide some kind of sprinkler system to the building, and then we could open up the stairwells. But since we don't have a sprinkler system, the stairwells have to be an enclosed shaft with a fire-rated wall totally around the stairway. So the stairwells will have doors to get into the stairwell, doors to get out of the stairwell. Okay, so we will have that. And again, those have to meet the 60-minute fire rating, and it'll be similar to the corridor wall system, except no sound deadening around the stairwells. No need to sound deaden the stairwell, except where the stairwell goes against an apartment unit. But 2 layers of 5/8 fire-rated sheetrock around those. Smoke detectors. Similar to residential construction, you have to have a smoke detector at the high point of the ceiling, and you have to have a minimum of 1 in every bedroom, sleeping area, and you have to have 1 in the corridor leading to or away from the bedroom area. In the common space, we also have to have some smoke detectors and some fire alerting devices. So in the common space, we have to have, again, smoke detectors in the stairwells, smoke detectors in the laundry room, smoke detectors in the mechanical room, and smoke detectors in the corridor space. And then we have to have, what's common is these strobe light type devices, and they alert people that there's a fire in that area. We would also have to have, I guess I don't show them here, but exit devices, lighted signs that tell you the direction of the exits. These doorways into stairwells and out of stairwells oftentimes get blocked open because people block them open to move furniture in and out of the building, or sometimes simply for ventilating the building they block them open. It's illegal to block them open with any kind of device that would prevent them from shutting automatically in the case of a fire. So it's a requirement that you put on these hold open devices, these magnetic hold open devices. And in that case, they're connected to the fire alarm system, and you can swing them open. They magnetically get held to a device that's on the wall that holds them open in the open position. When the fire alarm goes off, it releases the electricity to the electronic magnet, and the door will automatically shut. So you can have those kind of devices, but you cannot block the stairwell in any way, or block open the doors in any way. Okay, we will have, in some cases, self-closing hinges, and in some cases, door closers on different doors. So the doors that go into each apartment unit will have these self-closing spring hinge type hinges on the door. So the door will automatically go shut. If you open it, it won't stand open. It will automatically shut. Again, it's a fire code requirement that the doors automatically shut behind you. Doors that'll have door closers will be things like the main entrance doors to the building, the security door, stairwell doors, laundry room doors, things like that. But the apartment entrance doors will have the spring hinge. There will be panic bars. We're familiar with panic bars probably, meaning that if a door is shut and you run up against it in an emergency leaving the building and you just hit that panic bar, the door will automatically release and go open. You don't have to turn a knob or push a lever or anything. There will also be some push-pulls on doors that do not have any latches to them. The main outside entrance to the building is not secured by any kind of lock system, so it will have a simple push-pull on it, meaning there is no latch system there at all. You just push it or pull it and it will automatically open.